Hey Harbor Physics students, today's video is called Pagganck, which is the Lenape name for Governor's Island. It means nut island. Today we'll be thinking a lot about the position of objects in relation to space, otherwise known as the reference frame, and in relation to time. Here our reference frame is a bird's eye view of Governor's Island, oriented in a north-south direction with two pins indicating the ferry terminal and the New York Harbor School. Our learning objectives for today are: I can describe motion in terms of position and time rather than distance, and I can determine the average velocity of an object by determining the slope of a position versus time graph. Feel free to pause the video at any point and make sure that you read these objectives really carefully because it's important to know where you're headed and what you're going to learn today. Okay, let's get started. Let's get these out of the way and we'll move our key terms over to the left and let's start zooming in to Governor's Island. Let's picture the following scenario. You get off the ferry with your skateboard and you ride your skateboard down the main road and it takes you 3 minutes to get to the harbor school. Now let's look at the distance that you covered. So remember that distance is a scalar quantity, which means that it has a magnitude. It does not have a direction. And there's your distance, approximately 655 meters. The time it took, 3 minutes, or if I plug that into my calculator, 3 times 60 is 180 seconds. Now, if I was trying to determine speed, I would use the speed equation, which is speed equals distance over time, and 655 divided by 180 is approximately 3.64 meters per second. You'll recall that distance and speed are scalar quantities, and displacement and velocity are vector quantities. Now, distance and speed are a little more ambiguous because they only have a magnitude, whereas displacement and velocity have a magnitude and a direction. So watch how we determine displacement first. Displacement means your change in position, and it's labeled using the symbol delta x. Displacement is the vector whose length is the shortest distance from the initial to the final position. Another way to think of it is the expression, as the crow flies. All right, let's put our crow friend on the Corson, and she's going to take the shortest path to the harbor school, flying in a straight line. In this case, we would say that the crow's displacement was 525 meters, roughly west-southwest. Just as the speed formula is speed equals distance over time, the velocity formula is displacement over time. So let's take our crow again, and our crow is faster than the skateboard, so we'll say it takes her 1 minute to get to the harbor school, or 60 seconds. So our velocity is 525 divided by 60, which is 8.75 meters per second. And again, velocity is a vector quantity, so that's 8.75 meters per second west-southwest. Now let's consider another scenario and watch how we determine velocity from a position time graph. In this scenario, our reference frame is still the same, and we're going to consider that the positive direction is the direction from the ferry to the harbor school. Therefore, the starting position of our crow is at 525 meters. In the first 5 seconds, the crow flies 25 meters in the negative direction. For the next 5 seconds, the crow stays on the roof of the building at the same position. For the next 5 seconds, the crow flies 100 meters in the negative direction to grab a stick. The crow immediately turns around and brings the stick back to its nest on the roof. The crow then spends the next 5 seconds putting the stick into its nest. There you go, and this is what your position time graph should look like. And the next step is to determine the velocity of the crow. To do that, we need to determine the slope of the position time graph. And the formula for the slope of a graph is rise over run. So here between intervals 0 and 5, our rise is going to be 25 in the negative direction, so negative 25. And our run is 0 to 5, so is 5. So our slope is negative 5 meters per second. The key thing to remember is that the slope of the position time graph is going to be the height of your velocity time graph. So you're going to want to look for -5 here on your velocity time graph. The velocity is constant, so you just draw a straight line at -5 meters per second. Moving on to the interval between 5 and 10, the slope is 0. So now you just draw a straight horizontal line at v equals 0. Between 10 and 15 seconds, the rise is down by 100 meters, and the run is 5 meters, so our slope is negative 100 over 5, which is negative 20 meters per second. So now we come down here and we draw a horizontal line at negative 20. Between 15 and 20 seconds, the rise is up by 100 and the run is 5, so that's positive 20 meters per second. And the last interval, 20 to 25 seconds, the crow is standing still, so our velocity is 0. Just a quick note, if you look here and here, you'll notice that the velocities look like they're really far apart. It's important to realize that the speed is actually the same, right? The crow is going 20 meters per second. But in one case, it's going in the negative direction, and in the other case, it's going in the positive direction. So the velocities are different.